a little bit of explanation that we are about to do here. We have the scenario when we have deployed an AKS cluster version 1.27, and the thing is that we have been at the anatomy of the provisioner, which is the thing that that Karpenter uses, okay, to a CRD that Karpenter uses to choose which instances are launched at runtime. Okay, so right now we have a default provisioner that we have created, and the default provisioner, as you can see here, it does have a operator which is okay. We don't care if you're using a spot. You can use a spot. If you find any suitable instances that is a spot, please use it. Okay, and now we have excluded some very expensive instances of this type of family because we don't care. We are cost concerned, and the thing is that we don't want to spend too much doing this test. Okay, and another thing we have deployed here is the Karpenter with all the stuff, and we have a test deployment. And the test deployment that we're using is a simple deployment with 0 replicas at right now, and 0 replicas, and we will scale up this deployment to check how Karpenter works and how Karpenter creates new nodes to accommodate this and to place these workloads. Okay, and just to mention a little thing about how Karpenter was installed, it was installed using the Karpenter AKS blueprints. Okay, so the thing is that right now is I installed it with Terraform, and so the thing is that this code is available on the AWS site, and the AWS site on the AKS blueprints for Terraform. You can check this code, and you can download the code and use it in your own environments. Okay. So the default provisioner we have also installed KubeOps. KubeOps is tooling that it will graphically show how how the nodes have been created. So the thing is that right now they have this KubeOps, and we have only Fargate. We have created our AKS cluster with 2 Fargate profiles. So in theory, it's an serverless cluster where we're running our Karpenter controller. So the Karpenter controller is running on a Fargate profile. Okay. And right now we have some kind of and the other workloads are running here. Right now we have here it's only the Fargate workloads and the cluster system workloads. Okay, so you can check here is the Fargate nodes that are created, and we're going to about to start to scale our deployment. You can check down the logs on the Karpenter controller what it's doing to check for the thing is that we have scaled up our deployment to 5 pods. So the thing is it will try to create a instance type T3A small, which is the one that Karpenter has chosen among all the possible instances based on the requirements of our application, which will be CPU and this memory that we are requesting. Okay, Karpenter takes that into account and say, I need this kind of resources, so I will try to create this kind of instance. So if we are going here, we will see that the 5 pods has been allocated here. Okay, and Karpenter, we have created all the as you mentioned before. You can see all the labels that has been used in the node, and we can identify which node has been created, which topology is using, in which zone is created, which instance type which is T3A small, and which IP address and all the stuff here. And it's a spot machine. Okay.
Yeah, this is a spot T3A small instance because it's part of the definition of the provisioner. The provisioner said, I want the instances to be spot based, and I don't want them to be M6G, M6GD, R6G, etc. So it's by no surprise that the T3A small was chosen. And the strategy that Karpenter follows when choosing an instance type is based on a strategy called a EC2. It's called price and capacity optimized. That means that among the cheapest instances available, it will choose one where there's enough per capacity. There are not, and there are limits in the amount of resources that you can consume in Spot. And the Karpenter will query through an API call the Spot capacity and understand that there are plenty of T3A small instances, so there's very little chance that this type of instance is reclaimed, meaning that it would not be interrupted by AWS, right? So even though it's Spot instance, we can be pretty confident that it will not be removed in the next few minutes.
Okay, another thing that we can check with Karpenter is that we can get upper bound limits on the capacity that is provided by a single provisioner. So the thing is that, okay, don't get crazy, don't get over 1,000 CPUs, because no matter how much request you get, don't create unlimited amount of node, okay? Because the thing is that it's quite easy, because it will be, I don't have to create node pools, I don't have to define any other things, just a provider. And the thing is that it could be crazy, and then if I get enough workload, I will end up creating a limited amount of nodes. So I can limit the provisioner by setting up a CPU resource or a memory resource or an upper bound limit on a specific resource, okay? And the other one would be the node template that we have chosen before. The node template is just, we are placing the node on a subnet that has this label, and I am choosing to place the node with a security group that meets my requirement. This is here. I can put this discovery Karpenter, but I can put any label that I want, any tag value that I want, okay? In order to choose the where to launch my node.
Yeah, I think they asked Dylan.
And then we are going to scale to 10, and we will see another feature that offers Karpenter. Okay, so right now I'm going to check that the thing is that it's going to create another T3 small to place here. Karpenter works always on the when there are low capacity. Okay, that's the same that's the cloud scaler. Where are threads that are not being scheduled, that are pending scheduling. The thing is that Karpenter, okay, you have these requirements. I will have to create another node, place my new workloads. Okay.
Yeah. Okay.
But that's because it does have workloads that are in the schedule pending to be scheduled. Okay, that's the same that the class.scaler works. It's the same mechanism. So that means that you cannot have at the same time cloud.scaler and Karpenter. Okay, you have to choose between one of the of two. If you are using cloud.scaler, don't use Karpenter. If you're already using it, you will have to migrate. Okay. Another thing that is worth considering is the Karpenter does not run on Karpenter. That means that you have to place Karpenter on a node pool that is not managed by Karpenter. Okay, on nodes that are not managed by Karpenter, because if you are you risk the you are getting the risk of the node to be reclaimed by Karpenter at any moment. So the thing is that you need, in this case, we have provided two target profiles to run Karpenter. So the thing is that Karpenter is running on the namespaces where Karpenter profiles are installed, but it's not using Karpenter to manage Karpenter. Okay. Another thing, let's go and let's scale a little bit more to 50 replicas. And then you see the logs. Okay, I'm going to launch a machine with 40 pods request CPU. That means 40. Okay, so I have 40 pods in pending state,
So,
and that would mean that it will create another machine that will be dimensioned differently, because the requests that were made at the moment, it will greater. I will request more CPU. I will request more memory. So the thing is that the type of machine that will be created had to be, it will be optimized for that request. Okay. So the idea is that what is different for the cloud autoscaler. The cloud autoscaler won't take into consideration that, because it would only create the same type of instance all over again in the same managed node pool. So with Karpenter, you can check what it's doing, and the thing is that it is creating a new type of machine, completely different. It's reallocating some of the pods that we are located here. It's consolidating the pods into the bigger instances. So the thing is that it's reducing the amount of instances that are being created to reallocate and to reschedule the pods in another instances that is bigger. So that's what another of the things that Karpenter does very well is, and you can see it does it on a very quick. So the thing is that the same thing for cloud autoscaler does not work, because cloud autoscaler is not going to create a different type of instance to host and relocate all the workloads that I have. You need to be aware that not all the workloads can be relocated. This is only for demonstration purposes. Okay, I cannot, sometimes I cannot afford, okay, delete all these pods and move it to this one. But the thing is that Karpenter does it, and does it very good.
There's something we haven't mentioned before, and I think it's interesting to talk about, and that's expiration. Expiration is a setting that you can configure that allows you to ask Karpenter to auto-destroy instances after a certain amount of time. That's very interesting because you can force your EC2 instances to be recycled when you choose, meaning that from a security perspective, you are allowing EC2 instances to run for a limited amount of time. That means that your infrastructure will try to be as fresh as possible without the issue of having long-running instances that are subject to vulnerabilities, to problems with memory management. So I think it's a good idea to set an expiration time of few days or perhaps a couple of months maximum, and that will allow you to have a secure and optimized infrastructure.
I will end up going to replicas to zero, and that will make Karpenter to drain and code on the node which is not needed, and that will be all.